All right, let's talk about one of the biggest, most universal struggles in all of software: complexity. Today, we're going to break down the three hidden layers that create it, and even more importantly, how we can actually learn to manage it. It's a question that every single developer, every product owner, every tech lead has asked themselves at some point. Why do our systems get harder over time? I'm not just talking about bigger or having more features. I mean, genuinely, harder to change, harder to understand, and definitely harder to trust. What is actually going on under the hood? So, to start unpacking this, we actually need to go all the way back to 1986. That's when the legendary computer scientist Fred Brooks gave us a really powerful way to think about this. He pointed out that software complexity really comes in two main flavors. He called them inherent complexity and accidental complexity. Inherent is, the unavoidable messiness of the real-world problem you're trying to solve. And accidental, well, that's the mess we make all by ourselves through our own decisions. Let's dig into inherent complexity for a second. This stuff comes straight from the problem itself. I mean, if you're building a banking platform, you have to deal with regulations, you have to deal with fraud detection. It's just part of the deal. You can't code your way around it. It's the nature of the beast. It's just reality. And then you've got the other side of the coin, the complexity we can actually control. This is the accidental stuff we introduce ourselves. You know what I'm talking about: the tangled code, the confusing extra layers, the who owns this anyway problem. And of course, our good old friend, over-engineering. The key thing here, this part is totally self-inflicted. And what happens when we let both of these just run wild? Well, the consequences are pretty severe. As you can see here, your project costs just skyrocket, while your development velocity, your actual ability to get stuff done, just grinds to a halt. The whole system becomes fragile, everything gets delayed, and failures start popping up everywhere. And this really drives home the long-term financial pain. That initial build cost, that's often just the tip of the iceberg. Fast forward 5, 10 years, and the cost to just maintain, support, and navigate the system goes through the roof. Unmanaged complexity literally compounds, just like debt. Okay, so we've known about inherent and accidental complexity for decades now. We've got design patterns, we've got DevOps, we've got Agile. We have all these tools to fight it. So why is it still so incredibly hard to manage? Well, it turns out we've been missing a huge piece of the puzzle. And here comes the plot twist. It turns out there's a third, often invisible, layer of complexity. And this one doesn't emerge from the problem domain or even from the code itself. It emerges from us. We call it socio-technical complexity. See, software systems aren't just these abstract technical things. They're built and maintained by organizations full of people. And this complexity is born from all the friction and challenges of human coordination, how we all interact with the very technology we're trying to build. The guiding light for this idea is Conway's law. It's this famous observation from Melvin Conway that basically says, your system's architecture is destined to become a mirror image of your company's communication structure. So if your teams are fragmented and siloed, guess what? Your system is going to become fragmented and siloed too. Now, in a tiny team of, say, 5 people, this might be pretty subtle. You might not even notice it. But as your organization grows to 50 people, or 500, or 5,000, the challenge of just coordinating everyone absolutely explodes. And at that scale, socio-technical complexity often becomes the single most dominant force shaping your system. So now that we've got all 3 layers out on the table, let's put them all together into one single unified model. This is what gives us the complete picture of what we're really up against. It really boils down to just 3 words, 3 forces: reality, which is where your inherent complexity comes from; decisions, which is where your accidental complexity comes from; and coordination, which is where all that socio-technical complexity comes from. This visualizes it perfectly. You can almost think of it like an onion. At the very core, you've got the inherent complexity of the problem. Wrapped around that is the accidental complexity that we added from our own engineering decisions. And then, enveloping the entire thing, is the socio-technical complexity of our organization. They're all happening all at once. Okay, so now that we have this complete model, this map of the territory, the million-dollar question is, what do we do about it? And that brings us to the way forward, adopting a much more mature philosophy for actually governing complexity over the long haul. And here's maybe the most important insight of all. The goal is not and can never be to eliminate complexity. That's a fool's errand. The real craft is learning to tell the difference between the complexity that must exist and the complexity that should not. It's about respecting the inherent, fighting the accidental, and skillfully navigating the socio-technical. To really get good at this, we have to fundamentally change our perspective. We have to let this sink in. A system is not just code running on a server. It's way more than that. It's the sum of your team's best guesses about the future. It's the quality of communication between your people. It is, in a very real sense, your entire organization frozen in architecture.
And if that's true, it means the real craft of software engineering, well, it can't just be about building more features as fast as humanly possible.
No, the real craft is governing complexity over time. This is the paradigm shift. This is the core discipline that separates the systems that thrive and evolve from the ones that eventually collapse under their own weight. So I'll leave you with this one question to take back to your own work. The true quality of a system isn't really defined by how many features it has. It's defined by this: how gracefully does your system handle complexity?